In section 5, we're going to be dealing with, again, factoring trinomials, but now our A term, where it was 1 in the previous section, is not going to be a 1. And there are two methods that we use. The first method is undoing the FOIL, and the second method you'll see is called the A for this A here, C for this letter here, the AC method. So again, if we had this, we got this, how do we undo this? Well, when the A term here is not a 1, this creates a problem, well, a concern, that what factors do you put there? Well, here they're telling us it's a 3 and a 4. But when you just look at this A as being 12, it could have been 1 and 12, 2 and 6, 3 and 4. It's a 12. So here's where the artisan skill comes in. And they're giving us a protocol to do it. And it's sort of undoing the FOIL. So again, you can spend some time looking at that. I will get to work on an example and show you the technique. So again, is it in standard form? Yes. Is there any common factor you can factor out? No. So in undoing the FOIL, you're going to put two sets of parentheses. By the way, this method is referred to as trial and error, or guess. Let's spell it right here. And check. The others was a little bit of guess and check too. But now 3 is not a 1, but there's only one set of factors for it, so that works out very well. So we know it has to be a 3 and a 1 here that we don't write. Now for our 8, we have 1 times 8, 2 times 4, and that's about it. You could also have 4 times 2 and 8 times 1, but it's a version of these up here. So I'm going to eliminate these right away because 3 times 8 is 24, nowhere near a 10. So I'm going to try through trial and error, guess and check, to put this 2 and 4 here. And I have an eraser, and I hope you have one too. Now, when I do my foiling, I get a 12 and a 2. Oh, well, the difference is 10. Very good. I think I've got it right there. So what do I put here for a sign? Well, my middle sign is negative 10. So I need the larger one, which is the 12, to be negative. And this one will be positive. And that's how I went about figuring out how to do that. Now the book does build you up and give you a little more material if you need it. And they're showing you all of the possibilities you could have. But the only correct middle term was this one. Okay, let's look at example 2. Now, is it in standard form? Yes. Is there a common factor we can take out of each term? And the answer is yes. We can factor out x to the fourth. So we're going to get 6x squared minus 19x plus 10. Now notice what's left inside the parenthesis. There are no more common factors. So I'm going to put two parentheses. And here it gets sort of tricky because 6 now, there are two sets of factors. There's I'll put it down here. 2 times 3, 3 times 2, and I forgot the 6 times 1 and the 1 times 6. 4 possibilities. Now I look at my middle term and I see a 19. My last term is a 10. So it's probably not going to be these. So, but again, keep them in mind. It might be. So I like to, if it's a 6, I'm going to go 3x and a 2x. Now I have a 10, and factors of that are 10 times 1, 2 times 5, 5 times 2, and 1 times 10. Now I don't know which one's going to work, but again, I'm going to knock off these and then look at it. I just lucked out. 2 times 5. Because here this is a 4 and this is a 15. And that adds up to 19. And if they're both negative, I get my positive 10 for the last term. Wow. But again, part of it is I have experience doing this, but I'm trying to pass it on and not keep the tape too long. And of course you have some boxes here where you could fill in. Again, it's trial and error. They give you a lot of stuff there. Okay. Now, method 2, as I mentioned, is called the AC method. That is, when you look at the A term and the C term of your standard form, there is a certain protocol, a certain series of steps that you can do to solve equations, those in which A is not a 1. Now, the authors of the textbook give a little video lesson on this too, and it wouldn't hurt to watch someone else do it. But once again, we have ax squared plus bx plus c. And in the AC method, we're going to multiply the A term, which is a 6, by the C term, which is a 20. So we have AC equals 120. Now, what we want to look at is factors of 120 that will add up to our B term. So what are the factors of 120? Now, if you don't know that, a technique might be from earlier days. You can take a 2 out of there, and that will be 60. A 2 out of there, and that will be 30. A 2 out of there, and that will be 15. And then you can take a 3 out of there, and that will be 5. So you now have what is called the prime factorizations. Now you're looking for the number 23. Well, these are all factors. Notice if I multiply these three together, I get an 8. And if I multiply these two together, I get a 15. And 8 times 15 is 120. And 8 plus 15 add up to 23. Ah, I've got the right combination. So now what I'm going to do, I'm going to rewrite this equation such that I'm going to put these as factors for 23. Now I don't have a lot of room, so I'll write it right here. 6x squared plus 8x plus 15x, and then plus my 20. So now this trinomial is equal to this polynomial. I've just taken my b term and divided it into two factors that when I multiply them make the 120 of AC, but right now that's it. So what do I do next? Well, now what I'm going to do, I have four terms. I'm going to factor by grouping. One of the skills we worked on earlier. What can I take out of each of these two terms? Well, I can take out a 2x and I get 3x plus 4. Now if I take a 5 out of these, I get 3x plus 4. I now have common factors, and I just go 3x plus 4. That's these two. Put another parenthesis, and I get 2x plus 5. And if I FOIL this, I get my answer. Now, notice they had it backwards compared to how I did it, but I told you this is the way I do it. You can do it this way as well. That's fine. And that's the strategy then of using the AC method when you have A is not a 1 and you multiply A times C. You look for factors of that will add up to your B term. Divide the B into its two subfactors. These are equivalent. Then factor by grouping, and that's the technique. And this is what is described right here. And how do you check? You check by foiling. Now, if you need to go back and see it again, that will be fine. But I'm going to do number 3 here using the AC model. Think about it. What is A times C? A negative 24. Now we want our B to be factors of a negative 24. That's going to add up to a positive 10. Well, how about a 10? Let's see here. 2 times 12. Now, one of these need to be negative, and we want a positive 10. So this will be a negative 2 plus a positive 12. So when I add these up, I get a positive 10. Now what do? Well, I rewrite this. 3x squared minus 2x plus 12x minus 8. Now notice, a negative 2x and a plus 12x add up to my middle term. And how did I find it? By multiplying my a times c, figuring out what factors, and then what numbers would be equal to our b term, which is 10. Now, we're going to factor this by grouping. What can I take out of this first term here? An x. So I get 3x minus 2. What can I take out of these two terms? Well, a plus 4. And I get 3x minus 2. So again, this is going to be one factor. And I bring in my x plus 4. And if I FOIL it, I get my original trinomial. That if I did it the old-fashioned way, x times this, 4 times this, distribute, combine like terms, I get that. We are undoing our multiplying a binomial that we did in the traditional way before we introduced the FOIL. And now notice they put the 12 first. That's okay. You could do it either way. It comes out. Okay. And we checked it. Now, which way do you want to use? And again, the AC method is about 95% for sure that you're going to get your factors. But it takes a little more time than the traditional unfoiling. Now, for something like this that we had done earlier, notice you had this. What is your common factor? You could take out x to the 4th. Then we factored it into this, equal each of them to 0. And you got x to the 4th, divide both sides by x to the 4th. Well, no, you're going to get x to the 4th equals this. And that is equal to 0 anyway. Here we transpose the 2, becomes a positive 2, divide by 3. Transpose the 5, negative 5, becomes a positive 5, divide by 2. Those are your zeros. Okay? And we had done the factoring of this before. And if you were to graph that, it looks like so. And it shows you your answers. Again, we don't do it that way. We do it just by factoring. Okay, let's do this one from scratch. So we have f of x is equal to 3x squared minus 4x. And they're all saying that f of a is equal to 4. Well, we can substitute the a for our x's here. And we're going to end up with something like this. 3a squared minus 4a equals our 4 over here. So what do we need to do? Well, put this in standard form. So we get 3a squared minus 4a minus 4 equals 0. We now have it in standard form of the quadratic equation. We now will factor this. There are no common factors in that. This has to be a 3a. This is going to be an a here. Now we know it's not going to be a 4 times 1. It'll probably be a 2 and a 2 there. And you might say, how do I know? Because that would have made a 12 and no way to get a 4 out of there. So when I do my outers, I get a 6. When I do my inners, I get a 2, and the difference is 4. Needs to be negative. So this will be a negative 6a. A positive 2a gives me my negative 4a for the middle term. Now, we then equate each of these to 0. Solve each one. Transpose that becomes a negative 2 divided by 3, or a equals 2. And there are my answers. And if you put it in the graph, that's where they would cross the x-axis. These are your x-intercepts. And the official way to write the x-intercept, of course, was that 0, that 0. Okay. From scratch on that one. Okay, another little twist they give us is finding the domain. Now, when we are looking for the domain of something, we want to find those values of x that make our denominator a 0, because we have to exclude those. So all we do, just dealing with the denominator, we equal the denominator to 0, factor it, 5 and 3, this is going to be a plus, that's going to be a negative. So equal each of these to 0. So here this is going to be a positive 3. This is going to be a negative 5. So our domain then would be all real numbers, but x cannot be a 3 or a negative 5. Because if we put a 3 or a negative 5 in this denominator, it would make our denominator a 0. So we have to exclude those values. Now, how do we write this in interval notation? Well, another thing we might do too is graph it. So it's going to be all real numbers, but it can't be a negative 5, and it can't be a 3. So all of this would be darkened, this would be darkened, and this would be darkened. So x is all these numbers, but x cannot be a negative 5 or a 3. So writing this now into interval notation, it's coming from negative infinity up to negative 5, parenthesis. Then we have union, parenthesis. It's going to start with negative 5, go up to a 3, parenthesis, because 3 is not included, union, parenthesis, 3 again on the other side, And what am I doing here? Up to positive infinity. That's better. And that's what they have over here somewhere. Yeah, I just saw it there. Perfect. Okay? You'll be doing some of those. Okay, that'll wind this up in 25 minutes. Not too bad.